Today we are talking about the wireless thing only, okay? And in wireless, we will be focusing on Cisco products, like Cisco side, whatever we need to cover. We are just focusing on that because wireless is really very big thing, right?
Yes.
And in a very short introduction, if I need to give you, wireless technology means when you are transmitting the data, or maybe you can say information or the signals between the devices without the use of physical wired connection. Instead, it used what? The electromagnetic waves, like radio waves, microwaves, infrared radiations, to transmit and receive the information. Okay. So when I am saying, okay, we are just utilizing the electromagnetic waves, it doesn't mean that the wire solution is completely omitted. No, wired solution and wireless solutions are hand in hand. But for the end perspective, I am talking about. Is it fine?
Mm-hmm.
So what is
Can
Wi-Fi?
you expand your screen?
My screen is complete. Maybe if you can, just make it maximize from your side. It is completely there,
Yeah,
expanded.
I got it. Yeah,
Okay, okay.
I got it. Yeah.
So what I was saying is, yeah, I was talking about. Have you heard about the term Wi-Fi?
Yeah, yeah, yeah.
Very generic term, right?
Mm-hmm.
So Wi-Fi stands for Y means wireless. Okay. Fi
Okay.
means fidelity.
Mm.
So it is again a technology that allow devices to connect to the internet or maybe communicate with each other through the wireless range, but within the limited range. Maybe Wi-Fi is something which we use in the homes or office of the public places.
Mm.
But one thing very important what we need to understand here that Wi-Fi is really one of the fastest growing technology of all the types.
Mm-hmm.
Every device nowadays has the Wi-Fi chipset.
Mm.
Instead, client is every client is told IoT is just getting warmed up with the wireless. Okay, and
Mm.
there was one analyst report back published in 2011.
Mm.
Okay, that report, what they said that the number of wireless stations. Okay, one more thing, the clients which are going to the wireless, they are named as station. Okay, station.
Mm-hmm.
So that report said the number of wireless station versus wired stations on the internet will be likely flip up by 2015. So they were saying that by 2015 it will be same, but everything was beaten up in 2014, 1 year before.
Mm-hmm.
So you can see the future is very clear to us how much Wi-Fi usage is there in the network.
Mm-hmm.
Okay.
Mm-hmm.
Even if you remember back in 2014 or 2005, maybe 2005, you can say 2006, if
Mm.
you have 100 APs into your network, right? We used
Mm.
to say that, oh, it's a very large Wi-Fi network. But
Mm.
today, if you see the RF installation, the 3,000 or 4,000, devices are very common in the your campus deployment, or maybe if you have some kind of stadium, if you have some conference centers or metro deployments, or even in the hospitals, it is
Mm.
very common. So it means this technology is really very vast. Okay,
Mm.
it is spreading up really very very prompt way, I will say.
Yeah.
And reason why? Can you just tell me, name me any of the advantages, please?
Advantages is you have wireless access point, you have built-in antenna within the wireless access point.
So we can say with respect to the client mobility.
Mm-hmm.
Okay, maybe
Mm.
let me just
Like
copy that.
in my office in Honda in Markham, Ontario,
Mhm.
they have 20 access points in their each floor. There are about 4 5 floors. 20 access points, about nearly 20 access points on each floor.
So 20 into 5, only 100 access points are there. That's fine. Okay. So if you see, mobility is one thing. What mobility means, that the end clients like you or like any of the guest person is coming into your office, they can communicate without being physically connected anywhere to the workstation, right? Even from the first floor to the second floor, if you need to go, you just pick up your laptop or maybe your mobile or maybe your tab, and it is very much allowing for your greater mobility and flexibility, right? So mobility is one of the advantage. If I will say in a very broader view, the convenience. Okay. So now you see, wireless connection eliminate the need for the cables, for making the whole setup, putting the maintenance. Everything is now being avoided. Scalability is one of the thing. Like if you wanted to expand the wireless network, it can be expanded more easily if you compare than your wired network, right? Because wired networks, sometimes it will take, it's a very complex thing now when you need to do the cabling and everything. So it's really a demand for the cost, more labor, more complexity is there. So I will say scalability. Then accessibility. If you just talk about the accessibility, wireless technology enable communication in the area, like let us say under the stairs. Okay. If you are going in the basements, you don't want it to put your cables or stretch your cable till there, or for a very small part of the like cafeteria or maybe breakout area. You don't want to extend your wired connections over there. But for the wireless, you can just increase the range and it can be doable or achievable, right? On the other hand, there are some challenges also, or we can say there are some considerations also. Like what? Like interference. Okay. Interference is what? Interference means when wireless signal is affected by somebody, some other party, let us say some electronic devices or some physical barrier is there, like there is a wall, a metallic wall, which is, not allowing your signal to move through, right? So interference is a problem. Then you can have a problem with the security. Like if you have the wired connection, only the people who can enter into the room can, access the wired connection. But wireless network can be more vulnerable because unauthorized access can be leading the problems. Getting my point? Then third point is range. Range means later on I will talk about transmissions and everything. So range of the wireless communication is limited compared to your wired connections, right? Also the bandwidth, right? Though now if we compare the newer protocols, they are really very fast. But if we just compare with the wired connection, again we need to think about. Okay. But see, it all depends how our application is, what we need to do. So lot of things depends, like when we are creating the wireless topologies. Okay. If I talk about topology, wireless topology, okay, the wireless topology uses the star topology. How? Let us say there is an access point. There are, this is, let us say it is just sending all of the frequencies. Okay. There are some clients. Now, Wi-Fi network typically use the star topology where all the devices communicate with a central point and that central point is your AP. Right? Okay. Let's go ahead. Do you remember the Ethernet standard provided by IEEE?
Ethernet standard. No, I don't know.
Okay. It was 802.3, right? So this typically, talk about the, or maybe we can say define the standard for the wired local areas network, LAN, MAN, or WAN, whatever you say. It primarily focus on the physical and the data link layer of the OSI model. It specify how devices communicate over the wired connections. Okay. Whereas we will be going to talk about now for the wireless. Okay. Let me just jump to the next slide. So here there is a term named as WLAN collision. Okay. What the collision means? Collision simple meaning is to collide. Even if we just check about the English meaning, there is one car coming from here, second car is coming from here in the opposite direction on the same track, they will collide with each other. Now let me tell you one thing very important, very, very important. Your WLAN is half duplex. You are okay with the duplex thing? Half duplex, full duplex? Okay. Since it is half duplex, it means over the network, either it can transmit, or over the network, either it can listen, receive, or transmit. It is half duplex. So there are more chances for the collision. And how we can avoid this collision? To avoid this collision, we have something named as CSMA CA. C stands for carrier, S stands for sense, M stands for multiple access, C stands for collision avoidance. This is a protocol for your wireless standard. Wireless standard is named as 802.11. Whereas if we talk about your backdays for the Ethernet, which is 8.2.3, okay, 8.2.3, it is named as CSMA CD, collision detection. But here we have a protocol which is CSMA CA. Very important question with respect to the interview also. Okay. So it is CSMA CA. It is what is this? It is a protocol which is used only for the wireless networks to manage how device access a shared communication medium, because it is a shared medium, right? Either the devices can transmit or they can receive. So this communication medium, like radio frequency spectrum, in order to avoid your collision or maybe efficiently transmit the data, we required this protocol for avoiding collisions in the wireless network. Any doubt?
Yeah, no problem. So the interference is due to the interference of the electromagnetic signals, right?
Right. So all those things are the very standard things. Okay. Currently, I am just talking about the general stuff, and later on, I will be building up on the more technical. These all terms we should be aware about. Okay. So we were talking about CSMA CA.
Yeah.
These slides are very important. I came to know like what I was discussing. Okay. So we were talking about CSMA CA, that is carrier sense, right? What the carrier sensing means? See, let us say there is a device. and this device need to send the data to the AP. Okay.
Mhm.
Since there is no wired available there, it will send through the electromagnetic wave, right? So before transmitting this data, it will not just transmit the data. Before transmitting the data, this device will listen to this communication medium, and it will detect that either there are some ongoing transmissions going on or no. Let us say if this medium is busy, because as I told you, it is half duplex, right? If it is busy, how it can be busy? Because there can be more, devices who might be, transmitting the data at the same time.
So more number of electromagnetic waves, right? More number.
Everything. So if it is busy, then this device number 2 will wait till this communication medium is idle. Getting this point? So this is the meaning of carrier sensing. Okay. There is one more term here when I am talking about carrier sensing. That term is named as virtual carrier sensing. Okay. We can just add virtual in front of this. What virtual carrier sensing means, like in your wireless networks, as I told you, device will sense something, right? But a device cannot directly sense all the ongoing transmissions because there can be some hidden nodes also. Instead, what it will do, it uses some virtual carrier sensing based on some acknowledgement forms. So it will send some of the data and will receive the acknowledgement. If acknowledgement is received successfully, it means, it implies that your transmission is can be sent successfully without any collision. Got this point? Now let's come to the collision avoidance. So instead of allowing devices to transmit as soon as the medium is idle, CSMA CA introduced a mechanism named as delay mechanism. Okay. So what this delay mechanism is, like device generate a random back of time and wait until the medium remains idle for this specific time. Let us say it is microsecond, but for this microsecond, it will back off or it will reduce your all transmissions. So this random back off reduce the likelihood of multiple devices choosing the same time, and they might be colliding. Let us say if it is idle, at once everyone can send data. So that should not be the way. Okay.
So there is a delay, is it?
There is a delay. Yes, there is a delay.
So if it is idle, then they can transmit the data through the communication medium. If it's idle,
right.
So
Now,
if it's idle, you can transmit the data to the communication to electromagnetic waves. If it's idle, or the delay mechanism is it will wait for a few seconds before it sends the before it sends its idle, then it sends the traffic again over the communication medium in form of electromagnetic waves.
Right. Yeah. There are two more very important terms, RTS and CTS. Okay. So RTS means request to send. CTS means clear to send. Okay. Very important terms. For more efficient handling of the hidden node problem, your wireless devices uses the RTS and CTS frames. These are what? These are frames. So before transmitting the data, a device send RTS frame to receiver. So this device will send RTS frame to receiver. Okay. The receiver confirm it with the CTS that okay, you are clear to send. It confirm that it's ready to receive. So other device within the range listen to these control frames and defer their transmission. It again reducing the chance of hidden node collision. Got this point? So this device who will listen to it will defer their transmissions. Okay. So request to send and clear to send frames are used to enhance the virtual carrier sense process.
So basically, they'll wait for some time, right? That's it, right?
They will.
Yeah, because you don't want to send data at the same time through a communication to electromagnetic waves. It will wait for
They
some
can wait
time.
for
If it's clear, then it will send the transmission, right?
some.
All right. Yeah.
So yes, you are. So on your stations, this RTS and CTS are enabled. So every time station want to transmit, station means your end device. Okay. So every time your station wanted to send the data or a frame, it must perform the RTS CTS frame exchange prior to the normal data transmission. Is this part clear?
Yeah.
Very important terms these are. Okay, very basics but very important.
So prior to transmitting the data, they'll do the RTS and CTS prior to sending the data
Correct.
through electromagnetic signals wirelessly. They'll first do the RTS and CTS, and then after that, they'll send the data wirelessly through electromagnetic waves.
True.
Yeah.
Okay, now let's proceed then. This is wireless collision. Now let's talk about the characteristic of a RF wave, radio frequency wave. So when we are talking about, see, now we are transmitting the data on the waves, right? So you should be aware about little bit. There is a lot of physics, let me tell you, lot of physics behind these all of the stuff. But I won't be gonna cover all of those things. Otherwise, this class will be really, dull or boring. I will just touch only that part which is important or which is required. We need to understand about these fundamentals. Is it all right?
Okay.
Now, in the context of radio frequency waves or RF waves, there are some of the characteristics. Like the first thing is you can say wavelength. You can see here wavelength, right? What the wavelength is? Wavelength is a distance. Okay. Wavelength is a distance between two consecutive points, like from here to here, which is in a wave. And this is in the same phase. Phase means either it is positive or it is a negative shift. So currently we are just checking the positive. If you wanted to check the negative, you can just take the wavelength like this. It means they have completed one cycle. It is measured in your meter, okay, meters. But let me tell you, there is one more thing, two more things probably, or a lot of things, but what we need to discuss. That is frequency. Very important frequency. What frequency refer to? Frequency refer to, let me write down, number of complete cycles of the RF wave in 1 second. Okay, like in 1 second, how many cycles it it has completed, and this frequency is measured in hertz, megahertz, gigahertz, bit like that, kilohertz. So in RF communication, frequency determine the rate at which your wave oscillate or how many cycles occur per second or per unit of time. Is it fine?
Okay, so the entire wave's number of cycles is frequency in 1 second.
Number of cycles. Now let me tell you.
So here we have about 2, 3, 4, 5 cycles, right?
There can be. See, let us say this is 1 second. Okay. In this 1 second, this wave has completed 10. Okay. Again, there is 1 second. In this 1 second, this wave is completed only 2 or 3. In 1 second, there is a wave which completed maybe 50. So there can be different frequency range. Okay. And let me tell you, these different frequency range are allocated for various applications, such as your FM, your radio FM, right? Your television, maybe cellular communication, and blah, blah, blah. So depending upon frequency, this whole thing need to be under consideration. Is this point clear?
Okay, so this is the number of cycles within 1 second now. That's all.
That is what I have written over here. If you see, I write down over here. Number of complete cycles of the RF wave in 1 second, measure in hertz. Okay, this is hertz. And I talked about the wavelength, right? Wavelength is this. That is the distance between two consecutive points. Now, there is a relationship. That relationship you should aware of. There is a relationship between the wavelength and the frequency. And they are inversely proportional to each other. Okay? Wavelength, lambda, is equal to C divided by F. Lambda is wavelength. This is wavelength. What is C? C is the speed of light.
So wavelength is nothing but distance between two cycles.
Yes, I will tell you one more thing. In the very layman term, if you will ask, what wavelength is? Wavelength is nothing but it is like how much coverage you do. Getting my point? In a layman term, if you will ask what the wavelength is, I will say it is how much coverage your AP is covering.
Oh, coverage. Okay. So the greater number of wavelengths, the greater number of coverage.
So it means that if your coverage is more, it means your wavelength is more.
Oh, yes. Right. So it depends on the number of wavelengths, right? Coverage.
Right.
So if you have more wavelengths, then you'll have more coverage. If you have less wavelengths, you'll have less coverage, right?
Yes. So you can see here what I talked about. Lambda is equal to C divided by F. Lambda means wavelength, C means speed of light, F means frequency, which means lambda is inversely proportional to the frequency. If frequency is more, wavelength will be less. Vice versa. If frequency is less, wavelength will be more. Later on, I would be going to talk about 2.4 and 5, gigahertz of your frequency. So here, frequency is less. Wavelength is more. It means that your 2.4 gigahertz can go far more beyond than your gigahertz of signals.
So the more number of wavelengths, the lesser the frequency, is it?
Inversely proportional. They are inversely proportional to each other.
What's the formula again? C divided by?
Okay, let me just rub it and write down it very neatly again. Okay.
Okay.
It is lambda equal to T divided by F, where lambda means wavelength, C means speed of light, F means frequency. If you see their relation, lambda is inversely proportional to frequency, which means if frequency will be higher, lambda will be low, wavelength will be low. If, on the other hand, frequency is low, your lambda will be higher. Getting this point? And let me repeat the same thing again. If you have two signals, one from 2.4 gigahertz or megahertz, whatever, okay, one is going in the 5 channel, okay, which will go far beyond, this will go far beyond. Why? The wavelength will be more in this case because frequency is less.
Okay. So less than the frequency is number of cycles, right?
Right. In 1 second.
Okay. So it's inversely proportional to wavelength, is it?
Correct.
Okay. So the frequency is number of cycles per second, right? And frequency is inversely proportional to wavelengths. So more number of wavelengths, less frequency, less number of wavelengths, more frequency.
You are right. You are right.
Okay. So it's inversely proportional. Frequency and the wavelength are inversely proportional.
Inversely proportional to each other. Yeah.
Right.
Any doubt?
So more number of cycles, less number of frequencies. More less number of cycles, more frequency.
Right.
Okay.
These two concepts are clear to you?
Yeah, I got it.
Wavelength measured in what?
Hertz.
Sorry?
Hertz, right? Frequency?
No. That is frequency. Frequency is measured in hertz. But wavelength in meter. Okay. If we talk about wavelength, that is into meter. Now, let me talk about one more concept here. If we are talking about the characteristics, and that is amplitude. So amplitude is bit like here. The amplitude is this. If there is second range like this, so amplitude is this from the here, right? In technical term, if I wanted to say, I can say it refers to the maximum displacement of the wave from the equilibrium position. Okay. What is this? This is amplitude. And in context of RF wave, if you talk me what amplitude meaning is in a layman term, I will say strength of a signal or intensity of a signal. So higher the amplitude, it means it corresponding to a stronger signal, while a lower amplitude means weaker signal.
Okay, it's just the distance of the top portion, right? Top and the bottom portion, right? Distance.
From equilibrium position to what is the distance? We can say, if you want the technical term, I can say maximum displacement.
Right.
Displacement.
So the bigger the cycle, the bigger the curve,
Hmm.
more intensity.
More powerful, or more strength of the signal
Okay.
is.
So amplitude nothing but the distance between the horizontal line and the curve, right?
Yes.
Right.
Yes.
So amplitude is nothing but we have a horizontal line, and then amplitude is
Ye-
a distance from the horizontal line to the top portion. So more the cycle goes up, more signal will be there.
Correct. So these three things are clear to you.
Yes.
First, frequency.
Number of cycles in 1 second.
But what the frequency means? Wavelength.
Yeah.
What the
Inversely
wavelength
proportional.
means?
Inversely proportional wavelength.
Right. And the third is
Amplitude.
amplitude. Okay.
Okay.
Very important characteristics of your RF wave. Any doubt in these three things?
No, I got it.
Clear, huh?
Yeah. So amplitude is nothing but the strength of the signal, right?
Correct,
Okay.
correct.
The greater the curve goes up, goes down, greater will be the signal, right?
Greater is the signal.
Okay. And frequency is inversely proportional to the wavelength.
So let us say there is an AP.
Hmm.
There is one PC here, one PC here.
Mm-hmm.
Earlier, maybe amplitude is more,
Mm, mm, mm,
but till it is going to the AP, let us say amplitude is less.
mm,
Wavelength is same, frequency is same,
mm,
but amplitude is becoming low.
mm,
Getting my point?
mm, mm.
That is a technical thing. But in layman term, we can say signal is become weaker.
Okay.
Getting my point?
Yes.
No doubt till here?
No doubt, no doubt.
Good. Let us move there.
Mm,
Next point. There are two frequency bands because we are talking about frequency. Now let me talk about the two band. Okay, I am just giving the introduction. Later on, I would be coming more deeper on that. When we are talking about Wi-Fi, we need to aware about two bands. Okay, the two frequency bands are 2.4 gigahertz
mm-hmm,
and 5 gigahertz.
mm-hmm,
Okay, these bands lie within your radio frequency spectrum.
mm-hmm,
Are you getting my point?
mm-hmm,
And these are the two bands which are commonly used for your various wireless communication and networking technologies.
mm-hmm, mm-hmm,
What are these? These are your frequency bands. Okay.
mm-hmm,
Now let me just give a very brief overview about the 2.4 gigahertz. Okay. 2.4 gigahertz frequency band starting from 2.400 to 2.4835.
mm-hmm.
It is one of the most widely used frequency band for your wireless communication. Why? Due to
Mm-hmm.
its more availability, relatively very good propagation characteristics.
Mm-hmm.
Your Bluetooth devices, cordless phones, microwave ovens, Wi-Fi routers, all operate in 2.4 gigahertz band.
And this has got more number of cycles.
I'm sorry,
More number of cycles, right?
less. Why more?
It's inversely proportional to wavelength, right?
Right. But here, if you see, the frequency is 2.4, right? If
Mm,
you see the 5 is more than 2.4. So frequency is less over here. It means wavelength is more as compared to 5 gigahertz, where wavelength is less. It means 2.4. So what does it mean? There is an AP. There are two APs. One is on 2.4. One is on 5 gigahertz. 2.4 signal will go, let us say, till here. 5 signal will stop here. Higher the frequency, lower the distance. Getting my point?
Okay. So the frequency, if frequency is 5, wavelengths are less.
Yes.
Okay. So that
And
it won't be
5 gigahertz
the
start
coverage won't be
from.
there.
Sorry. Can you repeat?
The coverage is very less in 5
The
hertz because
coverage
this is
with respect to the 2.4 coverage will be less. Yes.
right. I got it.
5.925 gigahertz.
Mm-hmm.
This is the range.
So 2.4 will have more coverage because of the greater number of wave cycles, wavelengths.
Right.
2.4 got more number of wavelengths, more number of wave cycles. Coverage is more. Whereas 5 years, your wavelength is less, cycles are less, and coverage is less. But 2.4 is good, coverage is more, right? Okay. And wavelength is nothing but the distance between the between the two curves. Okay.
Right.
Okay. So
Now,
all the organizations are going for 2.4 now because it got greater coverage, is it?
yeah, it's a standard thing. Actually, it's not specific to some vendor. It is a standard thing I am teaching you currently.
Okay.
Nothing related to the vendor specific. These are the standard things what I am talking about.
So the production environment they use 2.4 or 5?
Both.
Both, huh?
Both. Do not get confused. When we will come to that, let me complete couple of more facts.
Okay.
Then you will understand. You will able to make it out. Okay. Now let me tell you one more thing. As I told you that in this range, because it is due to its popularity, like your Bluetooth devices, your cordless phone, okay, microwave oven, a lot of other things will operate into 2.4 gigahertz. It means more interference can be there. Secondly, it has less band. What are the bands? I will be gonna come to that in a moment. Okay, but it has less bands. Whereas 5 gigahertz have it offer higher data rate with respect to 2.4, and it has more bands. It means congestion with compared to the 2.4 band is less. And when we talk about newer standard like Wi-Fi 5, Wi-Fi 6, which provide very fast speed, okay, they use 5 gigahertz band for various, your wireless technologies. Even your point-to-point wireless radar system, they use 5 gigahertz. Got this point?
Okay.
Any doubts so far?
No.
Clear, huh?
Yes. So the 5 gigahertz, the coverage is less. 2.4, the coverage is more.
If you compare, with that, yes, you are.
Yeah. Okay, because already in 5 hertz, it's less number of wave cycles, so coverage is less. But in 2 hertz, you have more number of waves, so the coverage is more. 2 gigahertz.
So let us say in your organization you have only one AP. Okay, budget is only of one AP, and your PCs are like spreading very far. So if you enable only 5 gigahertz, whose range is like till here, what about these clients? Although these clients are not very important, they are the guest users. But even then, they should have this coverage, right? So for the same, we would be using 2.4 gigahertz. Coverage is more, though bandwidth can be less, right? But they will have, at least they will have the access. Getting my point? We cannot, restrict them to having the access.
So it's better to have 2.4 gigahertz then.
Right. So
Because
because that
more
is
coverage is more.
not only this. This is one of the use case for that, right? There can be different use case. Probably that decision is up to you. I am just coming to that. Okay. You can see the next slide. What I opened is just talking about the same, which is Wi-Fi frequency spectrum. 4 gigahertz and 5 gigahertz are the range of the frequency.
Okay.
And as I told you, these are the commonly used in your Wi-Fi connections. Either you would be having 2.4 or the 5. Difference between them two is the speed and coverage. If we talk about the coverage is more in 2.4. If we talk about speed is more in the 5 gigahertz. Getting my point?
Yeah. Right. Speed is less than 2.4, but the coverage is more. In 5 gigahertz, the speed is more, but coverage is less.
Higher the frequency, faster the speed. Right?
Okay.
But shortage range. Getting my point?
Yeah, I got it.
No doubt?
No doubt.
Perfect. So as I was telling you, 2.4 gigahertz has comparatively longer range.
Coverage is more.
Less speed.
Yes.
It will be slower. Okay.
Yeah.
Secondly, interference. Where the interference is more? In your 2.4 gigahertz. Currently, I am just telling you one point. I will, more talk about this point later on. It has 11 different channels, although there are 14, but I will come to this point later on. Okay. So let us say it has 11 different channels only, not more channels. But I am talking about 2.4 gigahertz. Relatively, it is cheaper.
So the interference is more in 2.4 gigahertz, huh?
Interference is more. Because see now, your microwave, one washing machine, AC, TV, or whatever you see, okay, everything works on the 2.4. Getting my point?
Why is interference more in 2.4?
Sorry?
Why is interference more in 2.4?
Okay. So as I was telling you, multiple devices operate in this band only, like cordless phone, microwave, ovens, etc. Got this point?
Okay. Multiple devices operate in this band. Okay. 2.4. Okay. So all the cordless phones and microwave and all that, it operates at 2.4 gigahertz.
Uses the 2.4 gigahertz. So if your AP is sending the data on 2.4, let us say these devices are also operating on 2.4, the interference is more. Getting this point?
Okay.
Now let's talk about 5 gigahertz. 5 gigahertz, if we talk about range with compared to the 2.4 is less. But if we talk about the speed is more. 1 point. It can go in the Gbps. But let us say if there is some wall or something, there is some object is there, the penetration is very less. But here in 2.4, penetration is more. They can go beyond these objects easily rather than your 5 gigahertz of frequency. But if you talk about interference in case of 5 gigahertz is less. Why? As I was telling you, it is utilizing only 11 channels. Okay. Out of 11, I will, as I was telling you, it has 14, but I am talking about 11. Even later on, I will just delete the 11 also. I will give you only 3. Okay. But not in this slide because otherwise you will get confused. So for the current time being, you just consider it has 11 channels. Here interference is less because the number of channels in this are 23 channels. Little bit expensive, yes. Okay. Expensive.
Okay,
And
so 5 gigahertz works in 23 channels, and 2 gigahertz works in 11 channels.
right.
Okay. And 5 gigahertz, the penetration is very weak. Penetration is very weak.
Even I will,
right?
make on this point later on. I will clear these points later on more, in a more broader way.
Okay, so 5 gigahertz works in 23 channels. The interference is less, and 2 gigahertz works in 11 channels. The interference is more. Okay. Okay. And 5 gigahertz the penetration is very less, whereas in 2 gigahertz penetration is more. You can go through a wall or a tower or whatever it is, right? Right. So you can go through the block, right?
Because
So go
wavelength is more, na? Wavelength is high
right.
in case of 2.4.
Right.
So far, any doubt?
Yeah. So 2.4 wavelengths are more, 5 gigahertz, 5 gigahertz wavelengths are less, right?
Wavelength is less. And
Okay,
why?
frequency,
Because
yeah.
as I told you earlier, wavelength is inversely proportional to frequency.
Frequency. Oh.
Here, when frequency is less, okay, wavelength will be high. When frequency
Yeah.
is more, wavelength will be less.
Yeah.
And wavelength is bit equivalent to, you can say, range. Till what range your signal will go. Any doubt?
No problem. So 2.4 has got a greater wavelength, and the range is better, and penetration is better. Whereas 5.4 the wavelength is less, range is less, penetration is less. All right.
Right. Clear?
Yeah. Got it.
Okay. Let me now talk more about this. So when I will say 2.4 gigahertz, it is better choice for the device that move around a lot because it has better performance while penetrating the objects.
Right.
And has extended range. So it has extended range and more penetration ability.
Yes.
I can say these two qualities are very much into that. So
Right.
if you are roaming very much in different rooms and still wanted to connect it with the Wi-Fi connection, better go with the 2.4 gigahertz, right?
Because range is more, penetration
Because
is more.
if your AP is here and you wanted to roam like till here, so you can. But let us say if somebody is sitting on the desk only, they are not roaming very much, they can connect it with 5 gigahertz. Why? Because you are nearby the router or the access point. You want to connect to the device and then you don't want it to roam so much. You just want it to be into your room only. Okay. You will be get benefited with the higher speed and maximize network performance. Got this point?
Mm.
Yes or no?
Yeah.
Okay. So the choice between 2.4 gigahertz and 5 gigahertz are depending upon multiple of the factors like number of the devices or maybe desired performance. Okay. Or maybe the devices has some regulations like our old laptops does not support on the 5 gigahertz. Okay.
Mm.
They will be only available on the 2.4 gigahertz only. So
Mm.
if you disable 2.4 from your AP, okay,
Mm.
all the
Mm.
old devices, old clients will
Mm.
be not able to log in. Are you getting my point? They won't be able to use your wireless thing.
Can you go in? What was saying?
What I mean to say that your devices
Mm-hmm.
should be compatible
Laptops.
with the new standards.
Mm.
If one of the device, let us say, if your 10 of the clients are using the old laptops or old mobiles or old, devices,
Mm. Mm.
they are not compatible with 5 gigahertz. So they will not
Mm.
be able to use your wireless connection. Okay.
Mm. Mm.
So that is the reason 2.4 should be there. You should not disable 2.4.
Right.
Second, I talked about lot of benefits with respect to the 2.4 and 5 gigahertz.
Right. Less interference. Right.
Less interference. Yes.
So in
In 5 gigahertz, less interference.
yeah, less interference. Because in 2.4 gigahertz you have 11 channels, and in 5 gigahertz you have 22 channels, right?
Hmm. Hmm.
So the interference is less in 5, and the interference is more in 2.4 because it's got only 11 channels.
Correct. Any doubt?
No problem.
Now let's talk about two more points.
Mm-hmm.
Okay.
Mm-hmm.
Here, if you see, there are 2 points named as RSSI and SNR.
Mm-hmm.
Very important terms with respect to your wireless study.
Mm-hmm.
RSSI means received signal
Mm-hmm.
strength indicator.
Mm-hmm.
SNR means signal to noise ratio. These 2 points are clear to you.
Mm-hmm.
So these two terms are very much usable when there are some kind of surveys need to be done. What is the RSSI? What is SNR? You should be aware. So our SSI is nothing but you can say it is kind of measurement you are using while you wanted to quantify your strength of radio signal. Okay, measurement system you can say. So it provide an indication, like as the name says, received signal strength indicator. It provide an indication of the power level of the received signal. When I'm saying power level, it means it is what we talked about, the characteristic. It is height, amplitude. No, getting my point. So you can just measure these power signals in the term of decibels.
Okay, this amplitude, right? Distance between the horizontal line and the curve, right?
Maybe I was just talking about that, but you can say RSSI is measured in decibels. Amplitude you can measure in meter also.
So RSS is nothing but the amplitude, right? Strength of the signal.
No. It is a measurement used in the wireless communication system to quantify the strength of the received signal. Okay. It is decibels, in the decibel. So if you talk about the unit which represent the power, maybe you can say milliwatt. Okay. So similarly, it is measured in decibel.
Okay.
Now, higher RSSI means when your RSSI is higher, it means
more signal.
The signal is also higher. When lower is the RSSI, it means signal is also lower. So it is really very crucial parameter for assessing the quality of your wireless connection. Okay. But let me tell you, it does not provide about the signal quality or the interference level. Why? Let us say you are receiving a very good signal. RSSI value is high, but actual signal was this. Rest of the thing is the noise, or maybe you can say interference, which is making the signal very strong. So RSSI does not provide the information. It does not provide the information about signal quality. Strength is good. Neither it talk about interference level. For the same, we need to talk about the second concept here, which is SNR. What the SNR is? SNR is
signal to noise ratio.
Right. So here if you see SNR, it is a measurement to quantify the ratio of the desired signal to the background noise through your communication system. Getting my point? Like you are receiving such a good quality, that is fine. Either it is a signal or the noise. SNR is usually also expressed in the dB. And a higher SNR value means good signal, because signal to noise ratio. Signal is good, noise is less. That is the reason you are receiving higher signal thing, right? So higher SNR suggests a clear and more reliable signal, which we cannot, expect from here. We can expect from SNR. That if SNR is high, it means signal is more reliable. Quality is also good, and signal is also good, because as SNR suggests that surrounding noise is less. Very important factor in determining the quality of the communication link, as it is directly impact the ability to correctly decode and interpret your transmitted information. Any doubt?
I got it. So RSSI is something about the strength of the signal.
Sorry?
RSSI is something about strength of the signal.
Strength of this. So if I will provide you summary, in summary, RSSI provide the information about the strength of the signal received, while SNR provide the information about the quality of the received signal by considering the ratio of the signal power and the background noise power. And both your RSSI and SNR both play a very important role in assessing the performance of your wireless communication systems, and both are used to make the decision about your signal reliability and link quality and maybe potential troubleshooting in various of the applications which uses the Wi-Fi network. Okay.
Okay, I got it. RSI is nothing but the strength of the signal, right? In decibels. Okay, which is the amplitude, right? Amplitude is the signal strength, right? And SNR is the quality of the signal, good quality of the gives you an estimate of the good quality of the signal as opposed to noise. Right? So RSI has got better signal strength, which in decibels. SNR gives you the quality of the signal in comparison with the noise ratio, because there could be some noise, right? Some kind of noise, right?
True.
Yeah. The noise could be anything. Like could be like any other laptops are sending some data through waves and all that. There could be some noise, right?
Correct.
Right? Okay.
So let us say if this user is sending some data, okay, some another user is also sending the data not to your AP but to some other AP, some other organization. They are on different floor. Okay. Here the organization is A, here the organization is B. This data maybe is the data for this AP, but for this AP it is a noise. Getting my point?
Can you go again?
Any non-desirable data is A and B are different organization on different floor.
Okay.
What I was saying is there are different organization. This is organization A, this is organization B.
Okay.
On the floor, two clients are talking with their APs. Okay. So when this client is sending the data, okay, and this data is also coming over here, it is a noise for APA.
Okay, clash between the signals in two different organizations.
Right.
Interference
also, noise, but it is creating the noise eventually, no?
Okay.
And with the data also there can be noise. Like you say, in day-to-day term, we used to say, no, there is a very background noise from your end. Can you please come closer to the phone? Right? Same noise here also.
Okay, the signals are mixed. Organization has got its own signals, and organization has got its own signals, right? Signals get interfered with each other, right? Interference. Right? That's the noise, right?
Right.
Noise is different organizations, and one client is sending data in one organization, other client is sending data in another organization. There are two access points. There is a clash of the signals, right? Okay, because it's interfering with each other. Signals interfering with each other, and there could be some noise, right?
Correct.
Right. That's why you have rogue access points. Right. For example, when I was going through my organization, they had something called rogue access points. That means access points which are not in their organization. access point which are outside the organization also, it detects that access point, which is not in the organization.
True. Rogue APIs we will be gonna read about.
Because there are some rogue access points which are outside the organization, but it still comes as an access point in our organization, the rogue access point.
True. Okay. So now let's come to the wireless standard. Who defined these standards? IEEE. Institute of Electrical and Electronics Engineer. Okay. And as I told you, IEEE 802.11 means wireless. Okay. 802.11 can be appended with multiple of the letters. There can be different letters. These 802.11 is followed by some of the letter or the combination of letter also. And this indicate a specific version. Version for what? We can say it is an amendment of the standard. Bit like you have spanning tree protocol, then RSTP, MSTP, lot of versions are there. Similarly, we are talking about wireless versions. Got this point?
Okay.
Now, let me talk about couple of them. So, as I told you, 802.11 was the initial one. Okay. Then 802.11b was introduced in 1999. It operates on your 2.4 gigahertz. And at that time, it was able to provide you 11 Mbps of the speed. Very much adopted during that days because of its affordability. And nowadays it's outdated. But yeah, it was really very much adopted. During the same year, one more protocol came. That was 802.11a. Okay. It was also introduced in your 1999. With the difference that it only operates on 5 gigahertz. Only on 5 gigahertz. But it can offer the data rates up to 54 Mbps. And I'm talking about what? 90s. At that time, you can judge which should be the more, like you can say, more lovable to the public. You can guess it.
Right.
11B. Because 11 Mbps at that time was very much. No? And it's 11A adaptation was limited because of higher cost of the devices and potential compatibility issues. It was not compatible with the 2.4 gigahertz devices. Got this point?
Yeah.
Later on, 802.11g came into the market. Talking about 802.11g.
Yeah.
So 802.11g was introduced in 2003. Okay.
Yeah.
And it operates in the frequency range of 2.4 gigahertz. Okay.
Yeah.
As your 802.11b was operating. But with faster speed was very much. At that time, it was providing 54 up to 54 Mbps. And it was backward compatible with 802.11b devices as well. So it got very popular for upgrading your older networks. Got this point?
Yeah.
Later on, 11N come into the market. I will be going to talk about 11N in a moment in more, granular way. But let me give you an overview with respect to this slide. This standard introduced in 2009 brought very much significant improvements in both the speed and the range. And the main thing for this standard is it can operate on 2.4 gigahertz and in 5 gigahertz port. Okay?
Yeah.
Up to 600 Mbps of the speed it can provide. It introduced something named as MIMO. Multiple input, multiple output technologies, which using multiple antenna to improve signal strength and reduce the dead spots. So for now, maybe you can just say that it introduced a lot of things. Okay, it is bit like a revolution in the wireless field. After that, there was lot of enhancements are there. Like in 2013, we had AC 802.11 AC. Operate only in 5 gigahertz. But speed is more even than your N. Right? But you can see A/N, B/G/N. Have you ever logged into the device? You see like that. Have you seen like that or no?
No, not seen.
Not aware, huh?
Yeah.
Okay. So in 2019, there was 802.11ax. Again, operate in 2 gigahertz and 5 gigahertz both. It is named as Wi-Fi 6. Okay. It uses some kind of technique, OFDMA. Maybe I will be coming to that. I don't want to touch that parts here on this slide. Let me maybe, when I will move ahead, I will be going to talk about it. But the main thing is what? Main thing is N was independent, right? N was independent. It can go with 2.4. It can go with 5 gigahertz. Both frequency bands it can adopted with. And maximum data rates was for the same was 600 Mbps as I told you. Very much faster, right? But as I told you, when AC came in 2014, then 802.11ax also come 2019. Okay, and it is named as Wi-Fi 6, Wi-Fi 5. There can be maybe in 2024 or somewhere, Wi-Fi 7 can also introduce. All of them are putting lot of improvement with respect to your data receiving and data transmission. Okay, like I was giving you some of the term MIMO. Have you heard about this MIMO ever?
No.
Okay, this is nothing. Let me tell you, this is multiple input and multiple output. It takes the advantage of your multiple antenna. Okay, let us say there is Wi-Fi. It has multiple antennas. Okay, it take advantage from these multiple antennas for both transmitting and receiving.
Okay.
So data can be simultaneously received and transmit by different antennas. Not only it resolve the issue of multipath, it enable the data transfer at the high speed by using your multiple transmitting antennas. So data rate is also increased. Even if you wanted to read more about it, MIMO has again can be categorized into two parts. That is single user MIMO and multi-user MIMO. SU MIMO or MU MIMO. You can see these terms. Single, I will just cover the terms into a very simple manner. The difference between SU MIMO can only transmit to a single device, whereas MU MIMO can transmit to the different devices simultaneously. So depending upon cost, depending upon your devices, you can utilize different type of technologies. Any doubt?
Yes, fine.
One more thing you can see here, the term named as special streams. This is again the multiplexing in your MIMO technique that is used to transmit independent stream to a single or multiple receivers simultaneously. Again, the same term I am talking about, that you can see these wordings also when you read about 802.11 different standards. So if you talk about the these terms, you would be able to relate like how it is useful. Any doubt?
No doubt.
So let me give you a very brief overview again, that earlier we have 80.11a in 1997. Then in 1999, we come up with 802.11b and 802.11a. Can you give me the difference between them?
That's more data transfer rate, right?
Right. Also, it is 2.4 gigahertz only, and it is 5 gigahertz.
Right.
So earlier 11A 1 or 2 Mbps. That's it. B 1 Mbps, 2 Mbps, 5 Mbps, or 5.5 and 11 Mbps. A 6 Mbps, 9 Mbps, 12 Mbps. Okay. 18 Mbps, 36 Mbps, 58. Oh, sorry, it was 54, 48, and 54 Mbps. After that, it go with 80.11a. Then 80.11a already we did. G. Okay. Then N. Then AC. Then AX. And lot of other standards. I hope it is clear to you. No doubt?
Yeah. No doubt. No.
Let's talk about something named as wireless channels. Here you can see a deeper look into your 2.4 gigahertz. Can you see this slide? What I was talking at that time, that you may have different channels. So 2.4 gigahertz, starting from 2.400 to 2.4835 gigahertz. In reality, you will get 14 channels. But why I was saying 11? Because 12 and 13 are only allowed by the FCC on low power level. And channel number 14 is banned, as it may interfere with the operation of microwave and other appliances directly than other channels. So remaining channels are from 1 to 11. Got this point?
Yeah.
Second thing, there is one more term we can talk about here, that is channel separation. The amount of difference between two channels, channel 1 and channel 2. Channel 2 start from here, like, okay, you can see, or maybe till here. Let me just remove this. So this amount of difference, right? This is a separation. What is the purpose of this separation? Is to make the distinction of the frequency, to avoid the occupying same radio space. If there is no separation, the connected devices could mix the signal. So there is some separation required, right? And we are talking about here 2.4 gigahertz range. Here, if you see, in the blue, there is 1. In the green, there is 6. And in the yellow, there is 11. They are the only non-overlapping channels. Later on, when we will be going to talk about some of the tool like Insider, you can able to see your wireless environment to select what right channel you need to come up with to avoid the interference and ultimately improve your 2.4 gigahertz performance. Okay. So here, if you see in this particular diagram, every channel is separated by, or it is, sorry. So what I was talking, yeah. Every channel is separated or is 20 megahertz wide. Every channel. So that is the reason these are the non-overlap. Is it fine? Any question?
Yeah, it's fine.
The channel centers are separated by 5 megahertz also. And the entire spectrum, if you will say, it is 100 megahertz wide. Okay. No question, huh?
Yeah, no problem. You're recording this, right? Yeah.
We are recording this, yes. Now, according to your 802.11 standard, which is the legacy one, there is a term named as DSSS channels. And they said that your channel should be separated with 30 megahertz at least spacing. It means channel 1, channel 6 and channel 11 are also not considered as overlapping, right? Because they are separated by 25 megahertz only. But later on, when 802.11b introduced, okay, it reduced that length to 25 megahertz, which is the same in between our 16 and 11. So 1611 in 802.11b are considered as our non-overlapping channels. Similarly, when different more modulation techniques are introduced, like ERP DSSS or ERP OFDM, what are those? I will be gonna come talk about these terms also. These also require 25 megahertz of separation, which is sufficing our requirement, and they are also considered these 1611 channels as non-overlapping channels. Any doubt?
No problem.
So there can be co-channel interference, CCIE, okay? Co-channel interference, which meaning that from two different radio transmitters, they are using the same channels. And it can be caused by the many of the factors, design issue, administrative issue. Okay, there can be a lot of the interference can be caused. Can be caused due to such kind of stuffs. And adjacent channel interference can also be there. But when you are designing your wireless network, let us say this is floor 1, this is floor 2, this is floor 3. So you will use in floor number 1 channel, 2, 6 channel, then 11, then again 1, then again 6. By this way, your co-channel interference or CCIE can be avoided. Are you getting my point?
Yeah.
This is also named as channel reuse. So we are reusing the channel, no? We can say it is a concept in your wireless networking that involve the efficient allocation and use of wireless channel to maximize the capacity and minimize the interference in your wireless network.
Okay.
Any doubt?
No problem. I'll go through the video once again and it'll be more clear, I think.
Sure. So it is the fundamental principle in designing and managing the wireless network, particularly in the scenario where multiple access points or the base stations share the same frequency. So your channel reuse help to ensure that adjacent or the overlapping cells can operate simultaneously without causing the excessive interference with each other.
Okay.
So you should be very much careful while doing the planning or managing your channel allocations, because wireless network can achieve higher capacity improvement. Performance can be improved. Okay, the interference can be reduced if your planning is correct and if you are reusing the channels properly. Any question?
No problem.
Done with it, huh?
Yeah.